If you can provide low-cost broadband internet, people will buy every ounce of it that they can get.
During my time here, Christian and I tried to get you to tweet more. It's probably great that we had to do that. You're too focused on building.
Right now, I just think we as a country have to get back to building things again. I'm very excited to say that the Andreessen Horowitz Growth Fund has led another round for Astranis. So we have brought on another $200 million of additional capital. That is allowing us to move out on these production plans to start truly scaling up production.
I'm curious what some of the major learnings or insights from that process have been for you.
I learned that the hard way, I think. Thanks to S3, maybe some other people will not have to learn that the hard way.
We're here at Astranis HQ Pier 70 in downtown San Francisco with CEO and co-founder John Gedmark for the final episode of 1 year of S3. And I have a bunch of questions I've always wanted to ask you, being an employee at your company for 2 years. I now get to ask you. So, well, my first question is, for anyone who hasn't watched the main episode, can you give a quick brief on what Astranis is?
At Astranis, we build small satellites for high orbits to help connect the world. And this is using a special orbit called geostationary orbit, where you can park a single satellite over a country or a part of the world and provide this very low-cost broadband service with just that one satellite.
Traditional geosatellites, I didn't know when I started Astranis, are the size of like one of the larger conference rooms here in the building of these school buses, double-decker buses, and no one had ever thought to make them smaller and mass manufacture them. Can you give some context on what you and Ryan back 8 years ago were thinking about and what led you to have this insight that basically no one else in the industry had?
Yeah, so it's an interesting question. I mean, if you take it all the way back to it was really like 2014, 2015, you had this massive wave of new companies that were all getting started, and they were all in low Earth orbit. And the reason that I think part of this wave happened was actually the industry had a Netscape moment for the first time. And that was a company called Skybox was acquired by Google for $500 million, cash. And that is actually, I don't know that it was cash. A company named Skybox was acquired by Google for $500 million. And that got the entire venture capital community to essentially wake up to not just, I think, space technology, but a broader swath of hard tech. And so that, I think, we really started to see for the first time the ball get rolling on getting funding for some harder things. And that included a huge number of new small satellite companies doing all kinds of things in space, but at a much lower, a much more low-cost way, and with a small satellite approach, where you now can put a large number of these small satellites, often for less than the cost that you used to be able to put up one large satellite. So that was the backdrop, right? All of this activity was happening. I was actually at an organization called the Commercial Spaceflight Federation, where I got to see a lot of the new space companies taking off. And it just became clear, looking across the industry, what everybody was doing, that there was this gap. Nobody was trying to do anything new or interesting in geo or these other high orbits, which historically have been so valuable for humankind.
Why? I want to ask you more about CSF, but why are these high orbits so valuable for someone who isn't a rocket scientist?
Yeah, so these orbits are sort of this magical thing, right? Which and the first person to really come up with and publicize the idea was actually sci-fi author Arthur C. Clarke. He realized from the basics of orbit mechanics that there's this special distance away from the Earth where you put a satellite, and that satellite will essentially become locked to the surface of the Earth. So as the Earth rotates, as it of course normally does, the satellite is in an orbit where it just tracks perfectly to the Earth's surface. So he came up with this idea, he publicized it, realized that it could be this like super valuable thing to just have this, essentially a giant tower, but the largest tower the world has ever seen, where you could look down and see almost a third of the Earth's surface from this one spot and just hang there, indefinitely. I mean, basically, as long as the satellite can last, it will be parked there. And that allows you to do all kinds of things. That allows you, this view that we call, it's really the ultimate high ground. You get to see the entire, this 1/3 of the Earth. It's from a fixed vantage point, so you get, full just 24/7 view of that, of everything that's happening. So you can do remote sensing from there. You can do communications from there, and you can do these in a very I think surprisingly in a very efficient and low cost way, because even though the satellites end up being quite complex and there's real challenges, they are actually quite hard to build. Should you get them up there and successfully get them operating, then they're just enormously valuable.
Why are they traditionally so expensive and hard to build?
There are cases where it makes sense for these satellites to be very large and essentially at this gigantic size that most of them are at today. I think, unfortunately, what you find is if you're really trying to optimize this overall system of not just the satellite, but then also all of the ground and everything that goes along with it, you can fall into this, this optimization curve where you're heading towards this local optima, and the satellites just want to keep getting bigger and bigger and bigger. If you go back to the very first GEO satellites that they put up in the earliest days of space, they actually were not that big. People think of them as big because they're big-ish compared to like CubeSats and things that people are launching in LEO today, but they weren't actually that big. They grew over time. There was sort of this pull towards making them bigger and bigger and bigger, get more power, and basically the entire industry just sort of got dragged into this local optima where things just make sense for them to be big. And then you get, they sort of got stuck there because there's this feedback loop where the bigger something is and the more expensive it is, then the rarer each one is. And especially so, just thinking about the US government and how they put up these big satellites, you see these effects where you have a big satellite program that's fully funded, and then you have a bunch of other people that come along and say, hey, well, that thing's going up anyway, there's not very many of them, can we add on my extra payload also? And then they start adding these extra things on there, and then it actually just gets bigger and bigger and bigger. It's like the classic negative feedback loop, where it's basically the bigger they are, the more things people try to pile on because they're so rare, and then they just get even bigger and more expensive as a result. You actually see this with the GPS constellation today. So the GPS satellites, there's 32 of them up there. They are big satellites, and they do not just do GPS. They have a bunch of other payloads on board that do other things for the US government. Why? Because people are like, oh, hey, these satellites are going up anyway, let me go and, let's go sort of lobby and see if we can get our extra thing added. And before you know it, they're even bigger and more expensive than they would have been.
So what was your kind of childhood, like high school, college age years? Were you thinking about like, I want to go build satellites for GEO? Like what was kind of like leading up to CSF basically?
Yeah, I mean, I knew that I wanted to do something in space since I was a little kid, for sure. Just reading, classic sci-fi authors, Arthur C. Clarke, Isaac Asimov, Robert Heinlein, and that especially Arthur C. Clarke, like that is true hard sci-fi, right? Like all of the physics is as accurate as he could get it. Everything is, it's trying to make it ultra realistic, and it just gives you this feeling that like, these things are actually possible. So the unfortunate thing was that the industry, when I was growing up, really stalled with the use of the space shuttle, right? The space shuttle became this, it was like this iconic, beautiful thing, but the reality is that it resulted in very expensive launch costs, and it crowded out a lot of competition. So you didn't have the competition that you would expect in a normal free market situation with many rockets all competing to try and see who can lower launch costs, right? Space shuttle had a very, I think, negative effect on that. And things just felt stalled for decades. And it was really only with the space shuttle's retirement, which really started in around 2008, and then new founders getting into the game, like Elon with SpaceX, that things started to turn around. You actually started to see real dedication to getting launch costs lower, and it turns out that's just the key enabling factor for the entire industry.
So what did you study in college? And like, you didn't go straight to doing CSF. You were, involved in a lot of organizations and things, but.
Oh, sure,
Yeah.
Yeah, so I went to Purdue for aerospace engineering, focused on rocket propulsion there. Purdue is the, and I will say this, shamelessly, Purdue is the #1 school in the world for rocket propulsion. I think undisputed. You go there and you can visit their rocket propulsion facilities sometime. It's like they have some stuff that's just out of this world. So, Purdue was this huge draw for me. Went there, studied aerospace engineering, built some rocket engines, fired some rocket engines, and just knew I was definitely in the right place. Then, actually, thinking back, there was like a few moments where I realized where the industry was heading, and it was a big deal. So when I started undergrad it was 1999. When you graduate from undergrad with a degree in aerospace engineering, it's like you're going to go work at one of the big aerospace companies. Or NASA.
Yeah.
Those are just sort of the options. There really was just like not a huge amount of options there. So, but luckily, while I was in undergrad, there was a sea change that was starting, and this was, so the X Prize was happening at that time, and so there was some news of some new space companies being started for that, and then there was Elon with SpaceX, and because he needed rocket propulsion engineers, one of the first places he went after he started SpaceX was he went to Purdue. And I still remember, getting this email from our professors like, hey, this entrepreneur is coming. He's starting a new rocket company, and he wants to pitch everyone on, he wants to give a talk on what his company's doing. And, the professor said something like,
what year is this?
This would have been 2003.
Cool.
2003, yeah. And the professor said something like, his email, I should really go dig up the email, because the email was like, I know it seems crazy, but, this guy is actually, it actually seems pretty legit, or something like that. So we show up, Elon gives his talk on, it's like, this is the earliest days of the company, so he's giving a PowerPoint presentation with basically pictures of their early CAD designs of the rocket. And, the room only had, 15, 20 people in it. And that was, that was where he drew a lot of the early rocket propulsion engineers for the company. Actually, several of my classmates went on to be the top rocket propulsion engineers, like in the history of SpaceX.
Wow.
And they're still doing some very cool stuff today. So, yeah, I remember that talk very well. And so then it was like, okay, new things are happening, and you don't have to go work at a big aerospace company. You can start a company of your own. That is an actual possibility, and you can make things happen. Like, that is just a different way to make things happen in space. And so I said, I have to get to Silicon Valley.
So why Silicon Valley versus like LA, traditional aerospace hub, or going wherever SpaceX was, or near NASA? Like, what about Silicon Valley fit in your mind?
Space needs money, and the money's in Silicon Valley. So that made it pretty simple. And also, it's like, you sort of hear about it. I mean, I had never been to Silicon Valley or Northern California at all. So, you sort of hear about it, you read these stories, great entrepreneurs, Hewlett Packard being started in a garage, Apple being started in a garage, and you just get the sense that this place, I mean, which is true, by the way, that there is like a magic in the air, right? Like you come here and immediately you can go to any event, any location, and just where people are building things and get the sense like this place is very different. People are willing to take risks. They're willing to, just like work every waking hour of the day to make some impossible thing possible. And importantly, the financial backers here, the VCs, are risk tolerant in a way that, there's nowhere else like it in the world. Like they absolutely are. They are willing to take a flyer on truly crazy ideas, right? So it's like that is something that is unique here. Yeah.
So then you are like, okay, there's this change in tides. I'm going to go to Silicon Valley. What do you kind of then do next?
Yeah. So the way I got to Silicon Valley is I applied for grad school in aerospace engineering at Stanford. And got in, actually thought about doing a PhD there, but, was like very clearly like, okay, if I actually put in, 5 or 7 years here or something, I would definitely be missing out on all of this, like, awesome new stuff that is happening. And from there, it was just like, learn as much as I could, go meet with people, they were starting companies, go talk to people. Stanford, one of the things is like they constantly have talks by founders that come and talk about starting companies. So like just went to as many of those as I could. And then basically tried to see how I could get my foot in the door in the industry like anybody else. And I called up, there was one of the speakers that had come in was a guy named Peter Diamandis, who had founded the X Prize. I had gotten beers with him afterwards. Like he was, just like, well, my flight's not until tomorrow. Anybody wants to go get, beers with me at the local, pub? Like, let's do it. And, it was one of those funny things. It's like, now he's famous, but at the time, this was like a long time ago, and only a handful of people ended up going out for beers with him. So I got his phone number and I called him. I just sort of called him one day out of the blue and said like, hey, I'm really passionate about some of these different problems and what we could do with space. And I'm ultimately interested in starting my own company. What would you recommend for me to get my foot in the door in this industry? And his answer was, oh, well, you should come work for me. And what he didn't tell me on that call was that it was an internship that was unpaid.
Never do.
A slight oversight there, I guess. I literally didn't figure that out until I had like shown up in Los Angeles at the office, ready to work. And I was like, oh, unpaid internship, got it. Okay. All right. I see it was going to be a little more challenging than I thought. So challenging to like, pay the bills.
Correct.
And that really it did. It let me get my foot in the door and meet all these amazing people in the industry, and ultimately led to what we're doing today at Astranis.
Where did CSF fit in all of this?
So as I was working at X Prize, Peter had this idea, which is that this new industry needed its own group where the companies could get together and debate different things that affected the entire industry, government regulations, policy. People were always talking about industry standards, things like that. And the problem was all of the existing groups for aerospace were completely dominated by the major aerospace defense primes, Boeing, Lockheed, Northrop Grumman. So you had to have a new group. You couldn't just like go do this as part of some existing group. So he actually got everybody to get all the CEOs together. Elon hosted the first couple meetings at his the SpaceX headquarters in El Segundo, and we got all these people in a room, and they debated this idea and ultimately agreed that it like, yes, they needed a new group where they could get together and not have these like, you know, and just have no big defense primes like in the room, you know, trying to steer the way things would go. So so that is how the Commercial Spaceflight Federation got started. These companies decided to do it. I was working on it at the time, just, you know, almost like a nights and weekends kind of thing, and they asked me to go and run it full time as executive director. So that's what I did.
And then what was so from the time you kind of transitioned to being the executive director and then your time there, what was the general experience like, and what did you learn? Because I feel like you sort of got this bird's eye view of the whole industry.
So, you know, the group started with just a handful of companies: SpaceX, Virgin Galactic, Blue Origin was an early member, and but then it quickly took off. I mean, it was just adding tons of new companies, and yeah, I had this bird's eye view of all of the new activity that's happening in the industry. So just got to see every new technology, new company that was being started. I went out to visit them all. You know, I just like made it a thing to get on an airplane as soon as I heard about some new company and go visit them, see if they were. Part of it was just like see if they were real. You know, like they were actually building things, or if they were just sort of pretending. You know, yeah, it was. I think it was through that I really got to see that there was this pretty major gap where nobody was doing anything new or interesting in geo.
And why do you think that was, or is? Because even still today, like there really isn't anyone else doing a ton in geo.
That is a great question, and I think the answer is that because it is hard. Geo is truly hard to build things for it. I mean, this is like real. You know, this is real hard tech. No joke.
Yeah.
You have, so it's a higher orbit, so it's harder to get to. So the set of propulsion, you know, the propulsion system or systems that you need to get up to these higher orbits it's just a lot harder. You need a lot more delta V. So you have to solve for that and basically almost design your satellite around it. You have really significant power and thermal challenges from operating something 24/7, right? It needs to work and be rock solid 24/7. Even in the case of you get into some of these eclipses, so you're in total darkness. So you have to be able to, you know, continue to power the payload through that. There's a lot to it, and then I think last but not least, there's the radiation challenge that we talked about, where it's like, you know, truly, it is a super harsh radiation environment, and designing everything from the ground up to be able to handle that is a huge deal. I mean, it took us years, yeah. And we've done dozens of radiation test campaigns to test our electronics and the components that we're going to use, right? Like, radiation testing is like, you literally you travel to a particle accelerator, and you put your you put, you know, it's like a particle accelerator like you hear about in the movies, except you're actually there putting your electronics, you know, at the business end of this thing, and it's just firing the particles directly into your electronics, and you see how it goes, and like sometimes it doesn't work, and you have to scrap things and start over. So that is hard.
I actually got to go and film like some of that testing, and we'll conveniently link the video that we made about that whole experience right here and explaining more in depth Astranis' technical moat on radiation. Well, the only other thing, we spent a lot of time talking about the past, which is awesome, but one other kind of piece that's missing is I always thought like, okay, you have this insane bird's eye view of the industry, this real understanding of the executive and the technical side of things in this gap. And then Ryan is sort of like the like another perfect half in terms of like he is a legend or becomes one while you're doing this at Planet. Can you kind of share what his background was and then how you guys decided to found Astranis?
Oh, for sure, yeah. I mean, so I met Ryan, oh man, I think it might be literally 20 years ago at this point. I would have to go check the date. I think it was literally 20 years ago that we met.
Cool.
We met through, so there's a student group for students who are passionate about space. You know, at college, there's like chapters on different campuses. I was actually the president of the Purdue chapter of SEDS. Ryan was the president of the MIT chapter of SEDS. I would also happen to mention that Jeff Bezos was the president of the Princeton chapter of SEDS. So we're a very good,
Yes.
we're a very good company there. And through that, Ryan and I got to meet and just you know some different projects we worked on together. You know, he was actually instrumental in sort of a rebirth of SEDS, where making it into more of a national organization where people from different universities around the country would actually get together. There had been sort of a drought where that hadn't been happening. So, you know, like true credit to him for helping basically like revive this organization. So we got to meet and, you know, stayed in touch. And then I think I heard from him just sort of out of the blue one day when he decided to take this job at Planet. And he was going to join as a, you know, I think it was an aerospace engineer. And, you know, he had some questions about it, about living in San Francisco. And when he flew in, I picked him up from the airport. And then we immediately started talking about new company ideas. So, you know, it was like, I think it was like literally before he even had his first day on the job, we were already talking about when he might quit that job and go do something else. But then, like, you know, he's so talented, he very quickly was in a position where he was leading both the mechanical engineering team and the electrical engineering team at the same time, both as manager and technical lead for both of those. So,
Which is pretty unheard of, like, to do both of those things.
Yeah. No, that's extremely rare. Oh, yes. No. He is truly a multifaceted engineer. He also, on the side, as a side hustle, he was also running a software startup that he founded, where he wrote all the software code for this software startup.
Huh.
So, I mean, I'll let him tell you about that sometime. But so, yeah, he you know, truly can do it all. So, yeah, that was I think it was pretty clear, like we were onto something when we even back when we first you know, linked up in San Francisco.
So there's, you know, obviously more questions I could ask about the very early days at Astranis. But again, I made a 40-minute sort of docuseries about this during my time here that I think is probably a better service to watch instead of you explaining it. But I would love to jump to the COVID story of Astranis. And like, I don't know, I think that would have been the kiss of death for most hardware companies of around that size if that happened to them. And I don't know, I think it's one of the coolest stories about like sort of Astranis grit, resilience, and problem solving. I was wondering if you could share that.
Oh, sure. Yeah, I think most people know that San Francisco was one of the like harshest lockdowns and earliest lockdowns,
Yeah.
but I'm not sure people outside of San Francisco actually know what it was like when, you know, I mean, it was something out of a movie, right?
Intense. Yeah.
Yeah, super intense. What happened was the government of San Francisco had this like secret meeting on a Monday, and it was Monday morning, and at 12 noon, they were going to announce that the city was going into complete and total lockdown, meaning you are not allowed to leave your house, and that it would go into effect at midnight that night. And this is such a like dramatic thing. I mean, I'm not sure we've ever had anything like that in all of like American history, right? This is like a huge deal, and I mean, you could debate the like legality of it or whatever, but like clearly it was going to be a massive deal, and there were like leaks that were coming out of this meeting in advance of the announcement. So we heard about it, I think, it like leaked to the news closer to like 11:15 a.m. And we were literally in the middle of our company all hands that we use to kick off every week, Monday morning. So while we're in this all hands meeting with the entire company, somebody sees online that there's this news story that the entire city is going to be locked down, where you can't leave your house, effective at midnight that night. And, it's just like very clear it was about to be pandemonium, right? I mean, think about like all the people running to the grocery store to try and stock up, people going to Costco. Like, don't even try to go to Costco in that situation. Like, that's going to be a madhouse. And, but we said, hey guys, like, if we're going to operate through this pandemic, we need volunteers to basically volunteer. We need people to volunteer to take hardware home from the office. We don't know if we're going to be able to get into the office. And so people started volunteering to take, pieces of hardware home. And then once you have hardware at home, actually, and it's you can actually like set it up so that people can remote in and run tests on that hardware, from their house. So it's like, as long as the hardware is in a place where someone can work on it with their hands on, some member of the team, and it's not just like locked in this building, no one can go inside, then the whole team can basically work on it, right? Can run tests, whatever. So it's just like, hey, we need people to volunteer to take hardware home. And the team, people stepped up, volunteered, started grabbing things, throwing them into boxes, putting them on carts, getting them out to their cars, and we sort of scattered all the hardware of the company across, people's homes and garages across the Bay Area, so we could keep working on this prototype satellite. And we managed to do it in, a couple hours. Get all that packed up, clear out the office, put the office into a state where we thought we could be sort of in like long-term storage, and it was madness.
So you and Ryan found Astranis 2015. You do Y Combinator, legendary startup accelerator that's now across the street from Astranis.
Oh yes.
And tour here frequently to show their batches what future success can look like, and hire a group of people. Get your first office, which is an apartment, and then you move to like 420 Bryant, which is the bigger place. What are some of the highlights or stories that come to mind from those very early first couple of years of Astranis?
Yeah, I mean, we truly started the company in, I think the equivalent of a garage, right?
Totally.
I mean, like all the stories you hear out of Silicon Valley about that are all true, and it's like, the scrappiest stuff you could imagine. We decided early on that we wanted to build something and launch it into space, even if it was just a small CubeSat, as fast as we could, and just sort of show that we could put something in space. It would work. We could navigate all of the like regulations and things, that we could talk to it. We could set up a ground network, and so we did that, but from essentially like a garage. And as one example, we decided to build our own clean room, and the team figured out that you could meet this like class 100,000 clean room spec by just cobbling together cheap plastic sheeting, a bunch of PVC pipes for the structure, and some basic like air filtering. And the plastic sheeting, actually, I later found out was shower curtains. They went to Home Depot and just got this, like the cheapest thing they could find was these shower curtains that were on sale. So like literally made this clean room out of shower curtains. But again, it worked. We got that satellite out the door, and we launched it, and it did the tests that we wanted to do.
And then that leads you up into the COVID story.
Right. So we raised our Series A from Andreessen Horowitz. I think the best venture capital investors in the entire world. And I'm very proud of that. We met with everybody in Silicon Valley. We got a lot of no's, but it turns out, they say fundraising success is getting 49 no's and one yes, and there's real truth to that. So with that capital, we were able to get this much larger, truly like our first real legit space, and start building the first real satellite that we were planning to build for a customer. And so we had moved in, and we decided first to build a prototype that would stay on the ground, but would otherwise have all of the subsystems of the satellite, and we would actually put it through thermal vacuum testing and all the rest. Yeah, we were just starting to put that prototype satellite together when when COVID happened.
You just brought up fundraising from Andreessen Horowitz, and I guess this is not public now, but by the time this episode comes out, it will be. But they've led another round for a recent round of funding, and now Astranis is I think raised close to $750 million. And I always joke that raising a few $1 million for a deep tech company today, at least, is not very hard. But once you get to the numbers that we're talking about that Astranis has raised, it's a totally different ballgame. I'm curious, what some of the major learnings or insights from that process have been for you.
Yeah, for sure. So I'm very excited to say that the Andreessen Horowitz Growth Fund has led another round for Astranis. So we have brought on another $200 million of additional capital. Closed that a couple weeks ago. And that is allowing us to move out on these production plans to start truly scaling up production for business, and then also to move forward on our next generation satellite design that we call the Omega. So we are very excited to have the capital to go do both those things. Now, to answer your question about the fundraising learnings, let me think about that.
Because it's just such a totally different scale of raising than traditional software raises. Smaller, kind of a lot of the startups in the city don't need to raise nowhere near that amount of money. And even early hardware startups don't raise that much money.
Yeah, I mean, so the important thing, truly, you really have to try to get on the other side of the table, put yourself in the shoes of the investor and understand their motivations and how they think about your company and what it means to not just invest in you today, but what that will look like in the future. And, this is true for software and hardware companies, but there has to be a roadmap for how you're going to raise, not just the capital you're raising today, but how you're going to raise these additional rounds of capital in the future where the company is scaling up and you're doing raises at these larger scales. And for each point along the way, you should have a milestone. This is the milestone that we hit. We've de-risked the business in these ways, and therefore we can justify this higher valuation, and there will be people interested in investing in us in the next stage. Now, I think a lot of software B2B SaaS, investors, a lot of VCs, they've done it enough times that they know what those milestones basically are. They want to make sure that you have this basic understanding of this need for a plan, but they're super familiar with it. For hard tech, it's very different, and actually it's even harder because each company is often a little bit different or a lot different of what those milestones should be.
Right.
So you have to be very explicit in laying that out for the investors. We are going with this money, we are going to accomplish this thing. That will show this progress and these de-riskings. And then that will allow us to raise the next round. And with that round, we'll do then these following things. And that'll allow us to raise the next round. And true hard tech, you need a lot of capital, so you may have to map that out many rounds into the future for them. But that is what you have to do, because they're not going to do that for you. Right. They're not going to be able to look at your business from the outside and just, magically understand what those milestones should be. You really have to think that through and walk them through it, right? That was one of the big lessons learned, I think, was it's just a lot of hard tech, it's just too new for them, and also different hard tech companies are different. It's on you to map that out, right? and unfortunately, like a lot of things with fundraising, if you fail to do that, they won't. It's not that they'll then ask you and you get this chance to show them. A lot of VCs they'll just never ask the question, and they will sort of know that something's missing from your plan, but it's never really made explicit, and you just get a no and you don't know why, right? So like, there's a lot that you have to learn. I think, well, I learned that the hard way, I think. Maybe hopefully with thanks to S3, maybe some other people will not have to learn that the hard way.
Yeah, thank you for sharing that. I mean, to go just a bit deeper on it, can you walk through like what some of those early milestone raises were in your mind? Like how you, like from pre-seed or seed, and how, like what you even like learned, like what are the kind of tenets that are good in designing these milestones for different raise rounds?
Yeah, for sure. So there's different kinds of, one way to think of it is there's different kinds of risks. And so there's an accomplishment of some kind that shows that you have de-risked this problem, that you've shown that, this is not a problem that's solvable, or you have solved it and you've put it behind you. So there are, and so there's technical progress you can make. There's commercial progress you can make, signing contracts with customers. And there's other things, there's regulatory, for some industries, or for some types of hard tech, actually their biggest risk is regulatory, right? And people don't really think about that, but those companies have to really think, what is this milestone that I can show investors that I can de-risk this major regulatory risk? So there's a bunch of different types, and you can draw out a roadmap. And by the way, it doesn't have to be perfect. Like no one's expecting you to have this perfect crystal ball of the future, right? It doesn't actually need to be this, things don't necessarily have to play out that way. That everybody knows that situations change. But just being able to map that out, right, and show that level of understanding, that is, I think, really the crux of it. So, for a space company, it's like there's some progress you can make with early prototype hardware on the ground. There's launching a satellite into space that's a test satellite. There's putting up a first commercial satellite on an actual contract with a customer and generating revenue. There is just signing large numbers of deals with prospective customers. Like there's a certain point where, there's sort of this and I have to imagine this is true for hard tech even more so than software. There is this go-to-market risk where people wonder, how are you going to even sell this thing? What does it even look like to go sell it? What does your sales team need to look like? Can you figure out what that sales team should look like? What is your marketing going to look like? And landing a couple of early deals where you actually get it signed, get a real contract signed, just shows that you understand the market and you have some ideas about how to go to market that are the right ideas. So, for us, it was like some combination of those things. I mean, it was different ones for different rounds, but all of those are good. Hard tech exists on this spectrum where they have very different levels of market risk. Okay, market risk is just like, is anyone going to want to buy this thing? So at one extreme end of the spectrum is like these new AI mobile devices, right? Where it's like, a Star Trek communicator that you can like tap and talk to an AI that's sitting in a little piece of jewelry or something on your chest. Like, sounds cool, but are people going to want to buy it? And technically, even maybe it's not that hard to pull off. And then there's like this product and market challenge. The other extreme end of that spectrum is a fusion reactor. Okay, it is super hard. It may not work at all, or is decades away from having any hope of succeeding. But if it works, is anybody worried that you're gonna, this basic almost free electrical power, like you're gonna be able to sell that? No, everybody needs electricity. They're gonna buy your electricity if it's way cheaper. And so like that is, someone who's building a fusion reactor, I just feel like probably doesn't have to spend any time trying to find customers to sign LOIs or something. Versus if you're on the other side of the spectrum, you got to figure out how to really show people that you know how this thing is going to make money, or if not, like how early on in the company's life you're going to de-risk the market risk. Like will people buy this thing? And you could do that. I mean, you could do that with pre-orders. You could do that with, just like getting a prototype out the door and do some early sales. So then the question is like, well, what do you do if you're a company that's somewhere in the middle? And arguably, we are a little more in the middle of that spectrum. We are not all the way on the fusion reactor side of the spectrum, but I think we're actually decently close to it, where if you can provide low-cost broadband internet, people will buy every ounce of it that they can get. So we took that, we certainly decided to do both, basically. We decided to take forward to investors this narrative that if we could build it, of course, people would buy it if it's, at this price point. There's just no question there. But then we went out and we set out, we made it a real effort to sell it anyway. And we did. So we signed early contracts, including a contract for our first satellite long before it ever went up. And I think if I could give advice to other hard tech founders is do the same. Like, just because you think there is very little market risk in what you're doing, do not rest on that. Go try and sell. And go, start it, because you never know what roadblocks you could run into where the investors are all of a sudden going to say, okay, well, yes, all the technology is cool, and we love you, the founder, but like, man, you just haven't sold anything. Like, you never want to be caught shorthanded in that way, right? So, like, I would say, you got to go and sell.
Astranis is doing pretty well on that goal too, with over $1 billion in commercial backlog today. But another customer, sort of in a different sort of tangent to that spectrum of consumer versus like consumers will definitely buy it if it exists, like a fusion reactor, is the government. And Astranis uniquely, not just with the recent Silicon Valley sort of hype cycle of doing defense technology, you guys are thinking about this from day one. And it is interesting too that, Andreessen Horowitz obviously is the sort of leader in this American dynamism movement and now has a fund in it. And Astranis is like a sort of flagship piece in that world in my mind. Specifically this idea of like, it's such a strong commercial use case of the most affordable dollar per megabit per second, as you say, internet, but also the military without much change to the product wants the same thing. Can you talk a little bit about that and why that is, and why aren't they just considering LEO? Why aren't they just considering staying with traditional big geos?
Yeah, for sure. I mean, so we were thinking about where there could be U.S. government applications from the early days, but we really didn't spend much time focusing on it. We were very focused on our commercial customer base. But it turns out that a lot of the advantages that we sought out and a lot of the things we decided to push ahead on for the commercial business have paid dividends when talking to the U.S. government customers. So the prime example of this is, a focus on reliability, and not just at the individual satellite level, but at the overall system level. Once you're putting up larger numbers of small satellites, and this is of course true with the LEO constellations, but it also can be, and we are making it true in GEO. You can put up a cluster of satellites, and we use it's more of a cluster than a constellation. If they are, because they're all, imagine they're all in like one orbital slot, right? All in the same physical location. Or the same physical volume, they're all in the same physical volume of space. So you put up, if you have a cluster of these small satellites operating, and a couple of them are designated as spares, then it turns out that the reliability of that system far exceeds the reliability you would get even in the most, hardened, most gold-plated big GEO satellite. You could spend infinite money on a big geosatellite and not get the reliability that you would get from having a larger number of small satellites with just 2 spares. It's just the way the math works out, right? You're able to get far, many nines of reliability that way. So that was part of the argument from sort of day one of going to the smaller satellite approach. And then it turned out to really matter to the US government for, they call it, the word they use is resiliency. And resiliency really means if our adversaries were to actually start taking out our satellites, how would we defend against that? The large geosatellites, like, there's real vulnerabilities there, right? And they're so expensive. I mean, military satellites are like $1 billion each. So there's only so many of them you would ever even be able to launch. It's just not that many for, might only have a handful that the entire armed services, is dependent on. It's this like critical infrastructure. And so being able to supplement that with this extra layer of a bunch of small satellites to provide this resiliency just turns out to be exactly what they were looking for. So yeah, we're very excited about moving forward on some US government programs where I think we can do some good things.
Astranis is now at the scale where there's like a ton of money raised. The team is much bigger. The facilities are built out. Like even when I started here 2 years ago, the TVAC chambers were just getting set up. And now there's this like full production line where like, I think when I joined, there was 1 satellite built, ready to be launched. Now from 0 to 1, there are 4 satellites built, and the exponential curve of sort of Astranis 24 a year is beginning to go up. I'm curious what the biggest learnings in your mind have been from building a satellite factory and focusing on mass production versus making bespoke systems.
Oh, for sure, yeah. I mean, well, I think it's hopefully by now it's no secret that production is hard. And, as Elon says, is like actually harder than designing the thing in the first place. And there's a lot of reasons for that. It's like, there's no one simple, single reason. It's this giant hairball of complex problems where, you have to do real pathfinding there. Like you have to learn by doing and actually build these things and try and get them out the door and run all the full suite of testing that you need and figure out what those tests should be and how to do those tests efficiently. The tests that we do on our satellites before we ship them out the door could easily take well over a year or more. I mean, 2 years.
Yeah.
The amount of testing we do on our satellites before we ship them out the door, like if you look at how long it takes them to do those same tests on a large geosatellite, could easily take over a year. They will take over a year to do that. We decided early on we weren't going to cut any corners on tests. We're going to do the same suite of tests on each satellite that goes out the door. We just have to do it more efficiently and faster. And so being able to map those out, have a lot of automation, have your tests dialed in software so you can run them over and over again if you need. Like there is a lot of challenge there that is just hard to solve from the outset. Like you really have to start. You have to actually start this process of going from 1 to n and fight your way through it in order to start getting to the other side.
During my time here, Christian and I tried to get you to tweet more. It's probably great that we had to do that. You're too focused on building. But one of the things we never had to get you to tweet about was the sort of concern about China's space production and launch capabilities against the US's. And it's like I'm curious if you could talk a little. I'm curious if you could talk a little bit about this as it relates to sort of the defense and selling to the government.
Yeah, for sure. I mean, it is a look. There's a good chance. Hopefully, it's a low probability, but there is a good chance that we are heading towards a true clash of civilizations here with China soon, like in the next few years. And unfortunately, I think people don't realize that we are already behind in some respects. A lot of people talk about how we're behind on shipbuilding, and China is building, far more ships than we are. I think the number I heard was 2 a month.
Yep.
A lot less people are talking about how far behind we are in how we're getting behind in space. China has built and launched a huge number of satellites to every orbit for every type of mission you can imagine. And I think people just aren't talking about it. So I've tried to raise some awareness to that. Usually people come back and say, oh, well, because of Starlink, US is launching more. And it's like, okay, well, yes, Starlink is awesome. I'm a huge Starlink fan, but like, that's one capability. China is launching every possible capability. They're launching their own, they put up their own GPS systems. They're building that out. They've put up huge geo comsats for military purposes. They're putting up their own LEO constellations. They have their own classified space plane that is, appears to be a total copy of our secret space plane. They have their own human spaceflight program with a crewed space station on orbit today that they send their astronauts, taikonauts, up to and back all the time, and they've made it totally routine. You don't hear about the Chinese space station, but I think that's because they're doing it so well, not because they're like struggling with it. So, and then most recently, they have surpassed us in our capability of landing things on the moon and then returning them to Earth. They have done lunar sample return missions, okay? And they're doing that not just to some random place on the moon, but to one of the most valuable pieces of real estate in the solar system, which is the parts of the moon that hold water ice. So we know we know with high probability that there's ice in the moon, deep in these craters near the South Pole, where it's basically the craters are in perpetual darkness. Okay, so because the sun never shines in these craters, there's never enough heat to heat up this ice that was deposited there millennia ago by comets, and so there could be, no one knows, there could be very large amounts of ice there. If you can mine that ice, then the moon becomes this gas station for the exploration of the rest of the solar system. And there's only so much of it. And I truly think that real estate is incredibly valuable. And there is a race to get back to the moon to start taking advantage of that. And I think we are losing that race. Like China is winning that race right now. It is not good. So, I think that it is incumbent upon us, American companies who are doing things in space, to move as fast as we can, see where we can be helpful, and hopefully we can, really kickstart this thing and get back in a leading position.
Whether with China or not, can you sort of paint the picture, like, for the non-space person, what conflict in space sort of looks like and means, whether it's on orbit or affecting ground operations? Because I think it's a huge focus right now. Obviously, like, the U.S. has created a new branch from the Air Force, the U.S. Space Force, which everyone thought was a meme when it happened, but it was like a real thing. And Astranis has a Phase 3 SBIR and other things with the Space Force. I'm curious if you can sort of paint the picture for someone who isn't familiar, like, what does that look like? What does it mean? Is it Star Wars? Is it jamming? Like, what are some of the main sort of conflicts that could happen up there?
Yeah, so I think I mentioned this earlier, but Space Force is responsible for buying and then launching and then operating the nation's these satellites that provide all these different services for the U.S. military. Two examples are communications and GPS, actually, just to name a couple. And so Space Force flies these satellites today, which, like we talked about, are these giant satellites, cost usually over $1 billion each. And they use those satellites to provide, connectivity or GPS services for the entire U.S. military, right? So it's like, that is what Space Force does. Yeah, so there is very real concern that our adversaries, with all this capability that they've demonstrated could really put those military satellites under threat. And that is just such a bad thing for so many reasons. We have to do everything we can to prevent that from happening. And the number one thing you can do is, I think, create a deterrent where if you can get enough capability up of small satellites, large enough volume of satellites, if you can launch enough satellites, right, and you get things at a low enough cost where you can launch many of them, then the benefit to an adversary of taking out a single satellite is just not that much benefit compared to if all you have is a handful of giant satellites. And there is a point at which the benefit they're getting is so small relative to the costs, which is, violating international norms. There would be all of this like outcry from the rest of the world if they started taking out satellites on orbit. That is like, hopefully you can dial it such that the cost to them compared to the benefit, the cost compared to the benefit means it's not even worth it for them to try. Right. So that is the real hope, is like provide this deterrent.
So obviously there's a lot going on in a variety of ways, and this next year and this next launch for Astranis is the first time Astranis is going from first to many and scaling to 24 a year, 100 by 2030. But even beyond that, which this is already a big task, where do you see Astranis looking in the far future?
Yeah, so I think we are uniquely positioned to help extend humanity's grasp beyond LEO into high orbits, but then, who knows from there? I think there is going to be a huge demand for new systems that can operate out in cislunar space, and then in other places like Lagrange points, where I think we are uniquely positioned to go and be helpful there. But there could be commercial applications out there, and there's U.S. government applications out there. There's one that's sort of partway in between, which is providing services for NASA as they build out our next phase of lunar capability. Right? They've said they wanted to do this commercially, and that can mean all kinds of things. That can mean lunar comms. That can mean transportation of cargo to the lunar surface. That can mean who knows, one day transportation of people. So there is a lot to do there, and I think people may not realize just how much how much opportunity there is. NASA's today, their budget today is $26 billion per year, and the majority of that they spend with industry to go build the things that need to be built to go serve their mission, right? So like that is that is a real addressable market. So that is like that's pretty cool to think about. And then look, I think we are going to pretty quickly get into a mode where we are just trying to launch as many of these satellites as we can. And there's not really an upper limit, because I think any amount of this capacity that we can launch to connect people around the world, they will gobble up in like that. It's just you get it up there and are providing it at a low enough price point, and people are going to use every bit of it that you can get up there. So, I would say between those two things, we're going to have our hands full.
In space and working at Astranis and people who are in our industry, like we all, I think, just take for granted sometimes and get why expanding humanity through the stars and putting more of humanity on the moon and doing more exploration is important. But why is it important to you? Why do you care about it? Why is it exciting to do this?
Oh man, that's a good question. Yeah, I mean, there's just so much that we don't know. And it's like I just do not think we're going to learn these things without actually physically going there. Going to other planets, getting to the surface of Mars, figuring out what happened to Mars. We know it used to be a wet planet that was covered in water. and really try to get to the bottom of some of life's deepest mysteries. I think it is incumbent on us to go push into the unknown on that as fast as we can. And what we've seen is that it always benefits us on Earth whenever we do that.
Yeah.
Right? That is like we can. There's an enormous amount of benefit we can get to the people of Earth by going and exploring beyond.
My last question I was asking these interviews is a little weird, but I think it's great to ask founders, and especially coming off an answer like that. But how would you describe your current life philosophy?
Right now, honestly, I just think we as a country have to get back to building things again. That is what is just very clear. You know, you look at like what it was like in past eras compared to today. I just think we have so much work to do to just get back to being able to like build things again, right? Everybody talks about the high-speed rail, debacle in California, here in California, and that is true. That's ridiculous. For that amount of money, there's so much we could be building right now. And the good news is there's this whole community of people, which I think they have uniquely had their story told by you, Jason. So thank you for that. That are just super hyped about going and building things. And we have needed that. We haven't had that in a very long time. Like, we need that so badly as a country and then, for the world. So that is what I wake up thinking about every day. And hopefully, not just here at Astranis, but how maybe I can help out other founders as they're getting started. And so, that's just like what we got to do.
Well, John, thank you for building Astranis and caring about the connectivity mission, caring about getting America building again, and hiring me for 2 years. I do appreciate that.
It was my pleasure. Thank you very much. All right, awesome. Yeah, thanks, Jason.
Dude.
I really appreciate it, man.
Dude, that went so well. Thank you.
Thank you.
There's so
Come here,
many-
bring it in.
Thanks for everything, man.